Okay, thanks for having patience, all participants. So let me start.
Okay, sir. Thank you, sir.
Mhm.
Now you can sit.
So good morning, all participants. This is Dr. Rajiv Kumar Tripathi, Assistant Professor in the Department of Electronics and Communication Engineering, NIT Delhi. I'm giving this expert lecture on this topic, data analytics in real-time systems, conducted by Goa Institute of Technology and Management, Lucknow, sponsored by Dr. APJ Abdul Kalam, Technical University, Lucknow. And this is 30th December 2020. So before starting this topic, some topics were there that machine learning. So before understanding the machine learning, I have two questions and how you feel about these questions. And these are very small questions, but we have to think about it differently. Then we understand the feeling of machine learning. So the first question is that what is the average age of the faculty in our institute? So what we will do to do this, for calculating the averages of the faculty, we have to get a data of age of all the faculty members, then sum all and divided by this number of the faculties, then we will get an exact number in case of average age. But what is the answer for the second question? How old are the faculty in our institute? So this question is, you can say, a rough questions, and then this is talking about something that even if we do not have some exact data of what is the exact age of the faculty of all the faculty members, we can roughly think or identify the faces of the uh, faculty members and guess that okay, he will be 35, like 40, some 50, like that, and then we can by guessing and having some probability, all that, and then we can make some average of that. So that will be the answer for the second question. So what is the first question, what is the second question? The first question is all about the mathematics, and second question is all about the statistics. Okay, so this machine learning is based on the two things, statistics and mathematics, and it is more about the statistics comparison to the mathematics. So how the mathematics and statistics are different? Mathematics and statistics are different in two ways. That mathematics is mostly deterministic, that it gives the exact value, and statistics generally is derived for the random outputs or probabilistic outputs, something like that. And the average and expected mean, that in the mathematics we try to find the average, and in the statistics we try to find the expected mean. So that overall the things difference between the mathematics and statistics come the exactness and uncertainty. That mathematics is solving problem toward the exactness, and uncertainty for the statistics. So what is machine learning? It is more about the statistical analysis using the mathematics. That means we have to perform the more where the things are not known. So if we use only mathematics, then we have to know the everything. Then because it is not no things are not known, so we have to perform the statistical analysis, and we have to perform this using the mathematics. So machine learning is more about the statistical analysis and comparison to the mathematics. And what it is exactly, it is that it is the technique by which the electronic devices learn without being explicitly programmed, and based on the learning we complete some task or generate some output or decision. That means we don't know the exact things, then we program our device that will take decision itself on certain inputs and which is trained for earlier. The machine is trained preferably earlier, and according to that, it will take a decision later on based on the previous trained data. So these statistical analysis are used using the mathematics for this is the overall machine learning. You can say that it will learn without being explicitly programmed. So steps of machine learning. What are the steps of machine learning? In the machine learning, we have to collect data. That if you want to perform some operation, so first the need is to collect the data, then prepare the input data. Okay, what the meaning of prepare the input data? Suppose we want to convert some data into the probabilistic data. So what the meaning of probabilistic data? That suppose we have given numbers from 1 to 100. Okay, all numbers are there 1 to 100, array of natural number 1 to 100. And if I ask you to convert into the probabilistic data, how you can convert it? Okay, so for conversion of these data, we have to sum all data and divide by each number. Okay, so that each number will be converted into the probability. So any data can be converted if you sum all the data and divide by the individual number. Okay, so the data will be converted into the probability data. So we can have a summation of all number equal to 1. So that is the nature of probability. So we, depending upon our need, we can convert our data or prepare our input data. Sometimes we require normalization. What is the normalization? We divide by the maximum amplitude of the data. That means the maximum amplitude lies 1, and so the data range is between 0 to 1. Okay, that is the normalization. So these types of the operations is performed during the preparation of the input data. We can make in ascending order, descending order. We can delete some outliers. We can include some more data points of our choice that this would be part of that. So these all things done in the preparation of the input data. Then we need to analyze our input data. That out of the data, which data is useful. Okay, we analyze the data, and the useful data is only used to train the program. After analyzing the input data, only useful input data is used for the training of the program. When this algorithm is trained, program is trained, then we test the algorithm, because whenever the input will come, we have to perform a right task. And if your algorithm is failing in that input, so that is useless algorithm that you have built it upon for the machine learning. So we have to test the algorithm also many times, and with the robustness, your algorithm should perform for the particular task. And if your algorithm is passed in various types of inputs, then we can say that your algorithm is okay and you can use this algorithm. So these are the common steps of machine learning. I hope many of you are doing all these things and have done all these things and learning very well all these things. So techniques used in the machine learning is divided. These are the 4 different techniques used in the machine learning, and these using the mathematical and statistical approaches, depending upon the mathematical and statistical approach, for the machine to learn the data or feedback provided from the sum output. We can learn from the data, and we can get feedback from the output also to learn the data. Okay, so these are the 4 techniques, and 4 techniques that supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning. So in supervised learning, the system learns from the data which is labeled. In unsupervised learning, data is not labeled. And in semi-supervised learning, some of the data is labeled and some of the data is not labeled. That is, the data is partially labeled. And in reinforcement learning, system learns exclusively from the series of reinforcement. Reinforcement means particular feedbacks. And I will say you, the human learning is most of the learning comes from the reinforcement learning. Okay, that we see the things, we see the inputs, we see, take the parents from our parents gives us the input. So from our childhood, we develop our thinking, logical thinking process in our mind. Okay, so reinforcement learning is the a most natural way of learning. So what is the meaning of labeling? That is, data is labeled. Labeling mean when we have some input data and corresponding output data, we know that when we have some input data and after performing some operation, if you know the corresponding output, then this term is known as the labeling. Okay, that means input and output relationship is known. Okay, so let me see all these four in detail. In supervised learning, so suppose there is data set of and uh, n terms, that is x1 to xn, and in which if all the data are labeled, that means we have corresponding output y, that y1 to n, y1 to n. So we can say that this process is known as the supervised learning. So what is supervised learning? In the supervised learning, we use to learn a mapping function. We have to learn a mapping function depending upon given input variable and the output variable. Okay, so this mapping function is learned through the program, that what will be the exact relationship from the available data. So for the new input data x, when some new input data, because this is the earlier input data x, which was it was available to us. When some new input data is coming and corresponding output variable y can be accurately predicted using this mapping function, which was established using the prior data. So this mapping function, this generation of mapping function is the only part of machine learning, that system is learning this mapping function, that this input is coming, this corresponding output will be there. Suppose this y equal to f of x is the function, then we can say that f of x is learned, then for corresponding input y will be the output. So we can say this mapping function is learned by the system, and that mapping function in future will provide us the what will be the output. Categories of supervised learning. This supervised learning categorized mainly into two main categories: classification and regression. So we will see this thing. So classification is the output variable. Okay, as I told you that there is input and output relationship in the supervised learning. So when the output variable is a category, such as tall, short, man, okay, color, red, blue, green, then we can say the performance of classification methods, okay, in accuracy. So output variable in case of classification will be always a subjective, not objective output. Subjective means it is some having property of the system. Okay, and the performance of a classification category in supervised learning is done by accuracy, that this is 90% accurate or 99% accurate. Your classification after performing the operation algorithm, how much accuracy you are getting for a particular task. Okay, so and examples of these binary classifications and support vector machines, others. So examples of a binary classification. Suppose bank want to calculate a customer, which is a customer are coming to that bank person, and they are want to see the low risk customer and high risk customer. When you go for a loan, they ask us that please provide your last 3 salary slip bank statements of last 4 months or 1 year. 1-year bank statement, and then they also ask for your income tax return. These 3 things they ask. So what they used to do, all these data, they check our income and savings. How much is our income and how much is our savings? So they can, based on these data provided by us, they make our a credit score. And if the credit score is good, they provide us a loan or something. And if our credit score is not good, they denied for the loan that our credit score is not good. So for this, they can use this. They use this type of algorithm of binary classification, that some customers are the low risk customers or high risk customers. Low risk customers mean that they have the bad credit score, and high risk customers are those who are having the good credit score. So after training with the past data, that past data means whatever document we have provided to them, they learn from the data, and the rule outcome of that, maybe this is the simplest rule. They may be using the many other rules to check us for this loan disbursement. So if income of a particular person is greater than some amount, theta 1 is some amount, okay, that the bank can decide that is their policies. And if saving is greater than some theta 2, then the person is at low risk, that income is also high and saving is also high, then the customer is having low risk customer, okay. And if it is not satisfying this condition, then the customer is of high risk customer. So this suitable values of theta 1, theta 2 can be decided by the bank whether they want to having high risk or low risk, depending upon this theta 1, theta 2. So if theta 1, theta 2 both will be large, the risk will be low. And if theta 1, theta 2 will be low, then the risk will be high for the banks. So this is the binary classification. And in this one, what we will have? We have input data of our accounts, details, incomes, and income tax returns of previous year. They all use as input data, and corresponding they will generate a mapping function, okay, for us, that whether this is the, you can say, so they can use the prior data also for the other customers that they have disbursed this bank loan for this type of incoming and saving. So they can learn from this also, and they can decide for the present input which is the coming as a new customer for them. So from the previous data, they can consider for the new customers also, to check whether the new customer is good or bad in terms of low risk and high risk. So I hope this binary classification is very much clear to you all. So now the second thing comes regression. So regression is similar to the classification, but here the output variable is a real value. So what is the difference between the supervised learning 2 main classification and the regression? In the classification, we have to just categorize this is or this is that or not. That is, it is category only output. But in case of regression, output variable is a real value. Okay, here we cannot have, in a regression, we cannot have a, you can say that a category. It must have a real value, such as marks of students, age of the group, price of some commodity. Thus, performance of regression methods measured in the case of mean square error and other objective parameters. Okay, in case of classification, we have seen we have the performance of any algorithm. We have measured in terms of accuracy. There we see the accuracy, but in case of regression, when we are having the exact output in terms of real values, okay, minus infinity to infinity, real values on real line. So the mean square error and the other objective parameters are comes into measurement of the accuracy, that how much performance is there for the particular regression method. Okay, so the algorithms used for this linear regression, the random forest regression, and many others are there. Okay, so now we see the example for linear regression. So develop a system which can predict a price of used cars. Okay, we want to develop a system like many car selling companies are there online, they are purchasing the car. So without first they try to fill the data that what are the that is brand, year, engine capacity, mileage, and how far you have driven this car, that how many kilometers the car is already used, and many others. So based on the prior data, they predict the price of the new car, and this is done through the linear regression. Okay, so let us see how we do it. So let X denotes the input attributes and Y predicted price of the car. So you see, I have written here X as a capital and Y is small. So YX is capital here because I have chosen this X as a matrix. Okay, from X1 to Xn, and Wn to Wn are the weights. Okay, weights of particular input. Okay, suppose that how many, the important, the company consider that how many kilometer car is already used is the most important factor, and this factor should give the more you can say weightage compared to the other. So we can adjust it here, that W1, W2, Wn, whatever the number is there. So we can adjust the weight of particular input. Okay, so and you see Y here, I have written Y as a small y. So small y means it is giving the single data output, that means a real value. Okay, and W naught is, you can say, the plus minus value. W naught may be negative also, because after, or maybe positive also, that after considering all these values, some value of car will come after considering all these factors. Okay, and this W naught will be the plus minus some value. So they predict the value something plus minus 10,000, plus minus 20,000, like that. Okay, so Y will be the overall predicted value depending upon the weights and the bias W naught. So this process will give us exact value of Y, that is in the real one. So this process is known as the linear regression. Okay, regression means just provide the exact outputs in terms of real things. So I think this is also clear to you all, that this regression. Okay, and how we do it here, that from the previous car sold and purchased like that, they generate, train of their system, and then when some new input car comes to sell for them, they predict the price of that. So they use this car, all car selling persons use this type of model, and different models will be there which they can use for the exact prediction of the price of the car which comes for selling in for those websites. Okay, so now we see this semi-supervised learning. So in semi-supervised learning, data is partially labeled. So is the data which is not labeled, some data is partially labeled, so that is good, that we can use that. You can see here that suppose total data is x1 to xn, and that divided into two parts, and 1 to m data, which is the label, that is corresponding y output is available. Okay, and from m plus 1 to n, the data is not labeled, that is known as the unlabeled data. So, and this n must be greater than m. So which is data is not labeled, is that data useful? Yes, this is useful, because this, using this data also we can predict something. This is not a useless data, which data is not labeled. This is also a useful data. And let me see that how we will use this unlabeled data in semi-supervised learning. And all the process, classification, regression, and all the methods are same, whatever the in the semi-supervised supervised learning was there, classification, regression, and others. Algorithms are same. But some methods are different. Initial methods are different. Okay, initial methods are different. So what are the initial methods? So these are different algorithms or methods are used to in the semi-supervised learning, where the data is partially labeled. That is the self-training and generative methods, mixture models. In mixture models, Gaussian mixture models is mainly used in the literature I have seen. Graph-based method, code training, semi-supervised, support vector machines. Okay, so these are the main different methods. I have discussed here the steps for the supervised learning, and this tells us the how the unlabeled data is also useful. So you see in step 1, split the labeled data instances into train and test sets. Okay, that means whatever the labeled data is there, we have to train our algorithm based on the labeled data. Okay, partially labeled mean whatever the labeled data is available, we can use to train our algorithm. Okay, and then use the train classifier to predict the class label for all unlabeled data. Whichever the data is unlabeled, that data is used to label using the this trained classifier, which is trained through the available, you can say, label data. Okay, so out of these predicted class labels, which are the highest probability being correct, are adopted as pseudo labels. So it is not like that you use the all the unlabeled data which was predicted as class labels. Okay, so out of that which you feel that this is the good, which is having the highest probability, use them as a pseudo labels, that assign some label to them. Okay, and concatenate the pseudo label data with the label data for training data. Then retrain the classifier and combine the pseudo label data and label data again and again. Okay, so again the class this train classifier predict the class of label of the unlabeled data, and evaluate the again classifier performance of your matrix, and repeat step 1 to 4 until no more unlabeled data is remains. That means we have to label all the data using the available label data. So this is the technique used in self-training in semi-supervised learning. Okay, so unlabeled data is also useful, and that can be trained and labeled. Okay, using the labeled data actually present, we can label the unlabeled data also. Some of during the using a iterative process, and this after iterative process we can say we can train all the unlabeled data into labeled data. So I hope this is also clear to you all that how we use self-training in the semi-supervised learning. In unsupervised learning, no data is labeled. Okay, an example of this is clustering. When there is no data is then we have to see some properties that how to divide into 2 parts, 3 parts. Okay, that is the clustering. We will see clustering in detail further on also. So in the reinforcement learning, here the agents are trained on a reward and punishment mechanism as we teach our children. Okay, that if you do good, you will get reward. If you do not, if they do something bad, we punish them. And so they learn it that they should not do this and they should do this. This is good, this is bad, this is good, this is bad. Up to the age of particular, till you are able to make them learn. Okay, and that's how their mind is trained to perform something good or bad. They know that if you touch the hot things, it will harm you. So that is sometimes they understand by your warning, or sometimes they learn after touching it. So whatever the method, the reinforcement learning is the process where it is training done for the algorithm through the reward and punishment. And this is the most natural process I found it. that it is done for all of us throughout lifelong. And the agent is rewarded when the correct moves are there and punished when the wrong ones are there. So in doing so, the agent tries to minimize wrong moves and maximize the right ones. So that's how this algorithm, reinforcement algorithm learning works. An example for this application in self-driving cars. So self-driving cars now is going to come soon. So they are making a perfect algorithms that will drive themselves. And I have seen one video also very recently in China. Some scientists from USA, which came from USA, have done the trial for the perfectly self-driving cars for a few kilometers. And other applications, many applications are there for reinforcement learning. So, but you can say this machine learning is just developed in recent past to perform the different tasks which were not earlier possible to the normal things. So this is the machine learning. You can say the using the computation, we are performing the desired tasks. And this natural language processing, when we process the language and use this output, that is so it is used in reinforcement learning only. So clustering. What is clustering? Clustering, we have to make a collection of data objects. And how we make a cluster? That in one cluster, all the components are which we put, that must have more similarity. And from the other cluster, they must have more dissimilarity. Okay, so similar to your own cluster and more dissimilar to your other cluster. And this is one more big difference between the clustering and partitioning. In partitioning, we don't see that whether it is dissimilar or not to other partitions. Okay, but in clustering, we have to see the dissimilarity also. In partitioning, we just partition 2 or 3 like that. We see that this is similar group, then we can partition like this. But we don't see the dissimilarity. But in case of clustering, the dissimilarities also play an important role. It must be dissimilar to the other cluster. These 4 types of clustering mostly used, I have found it in literature: partitioning method, hierarchical method, density-based method, grid-based method, grid-based method. So in the partitioning methods, mainly the distance-based method, these are the partitioning methods are mainly distance-based, effective for small and medium-sized data sets. An example, k-means and k-median. Clustering is hierarchical methods. Clustering is performed in multiple levels or tiers. Okay, and mainly 2 approaches are there, and 2 algorithms are based on that. That is agglomerative hierarchical clustering, divisive hierarchical clustering. In agglomerative hierarchical clustering, a bottom-up strategy is used. That means we can consider that each individual node as a cluster, then we join different clusters. And top down means we consider the all as a cluster and then we divide further on in divisive hierarchical clustering. And most of the faculty have done something research in WSN also. So Leech is the one of the example for the hierarchical clustering, where we divide into the different clusters. And this Birch also balance iterative reducing clustering using hierarchy is also example for this clustering of hierarchical clustering. Clustering using density-based method. Clusters are dense regions of the object in space that are separated by the low density regions. So each cluster center must have minimum number of points within its neighborhood. That we have to see that this number of nodes points would be there in its neighborhood, then we will assign as a cluster. Okay, so this method is mainly filter the outliers very easily and suitable for the arbitrary shape cluster. An example for most used density-based method is density-based spatial clustering for application with noise, that DBS CAN, DBS CAN. Clustering using grid-based method. Use a multi-resolution grid data structure for fast processing time. We can use this grid-based method, typically independent from the data objects, yet dependent upon the grid size. Because we have to divide all the data into grids, so it is independent of the data objects, and it will depend upon the grid size. This statistical information grid approach, string, wave cluster, and clustering in Quest click are the example for the grid-based method. Neural network is essentially part of deep learning, which in turn is subset of machine learning. And neural networks are highly advanced application for machine learning. Okay, so we will just go through something deep inside the neural network. One example. So what is the basic of neural network? Humans have 10 to power 11 interconnected neurons in their brain, and some of the neural structure exist at the birth and remaining grow with experience. Out of 10 to power 11, some exist at birth itself and remaining grow with experience, with the feedback, our experience, decisions, inputs from parents, teachers, everything. Okay, this structure is developing. Similar to the brain neurons, artificial neurons can be realized as an elements in a program and perhaps as a circuit as made of silicon. Okay, so these artificial neurons just lead this subject neural network. Network of these artificial neurons is called neural network and sometimes also called artificial neural network. So similar to the brain, these artificial neurons can be trained to perform useful function. So mathematical model of neurons is also known as the perceptron. So the single input neuron, you can say like that, where P is the input, W is your scalar weight, B is your bias, where bias will be add, P and W will get multiplied, and B is the bias we add, and this N is just equal to WP plus B is passed through a function that is known as a transfer function, is also known as the activation function, and the A is the output, that is the neuron output. So in the neural network, the adjusted this W and B, the finding W and B weights and the bias, okay, are adjusted by learning so that the input output relationship meets some specific goal. That means learning of this weight and base is the main aim of the neural network in the machine learning. Okay, because we know the input, we want to perform certain task. That task must be like that in a similar manner as its desired goal. So what will be the weight and base? This bias B. Okay, so this is the single input neuron like this. Okay, so you see here What is transfer function? Transfer function may be linear or non-linear function of n, and particular transfer function for a specific problem. Lots of transfer functions are in literature. Most commonly used transfer functions are hard limit transfer function, linear transfer function, and log sigmoid transfer function. Just a minute. Why it is not? Okay. So what is the hard limit transfer function? Hard limit transfer function is used to classify input into two distinct categories. That means, as I have given a equal to hard limit n. So when n is greater than 0, this will be equal to 1, and less than 0 equal to 0. Okay, and sign of this is this one, that 0 and going is up like that one. So when we use n as wp plus b, and you see all WPB or the scalars are here only, so that this value, this will shift to minus b by w here. So this n will depend upon, because this is the function of p. Here the x-axis independent variable is p. So at p equal to minus b by w, this will become 0. So this a becomes 0 when p is less than p by w, and equal to 1 when greater than p by w. This is for single input neuron. Linear transfer function. In a linear transfer function, so one more thing, that hard limit is used where the classification comes. There we used in the neural network that linear transfer function used in adaptive linear neuron network, that is known as the Adaline network. An output linear transfer function is equal to its input. Whenever this, whatever the input is n is coming, it will followed by that. And in case of n equal to wp plus b, so it will a line which is cross at y, this add equal to b, and this is minus b by w, and the sign of is this one, like this one. Log sigmoid transfer function is used mainly for multi-layer networks that are the trained using the Bragg propagation algorithm, and the output is given by a equal to 1 plus e to power n. And these are the different relationship between n and a, and p and a, and sign off is this, like this one. Now we see multiple input neuron. In multiple input neuron, earlier there was only single input, and here you see the multiple inputs are p1 to pr, r different inputs are there, and you see the weights are w11 to w1r. Okay, here we can take w1 to wr also, but because of when we have multiple layer of these neurons, then we have to differentiate it again. So that's why this 1r is taken for the neuron. The first one is the for neuron number. Okay, so here you see I have written this capital W and P. So capital W is a matrix of W1 cross R, and P is your R cross 1. Okay, and so n output will be the multiplication of these two matrices. So that will be equal to W11 into P1, W1 to P2 up to W1R into PR plus B, and n equal to WP plus B. And shortened or abbreviated notation for the multiple input neuron can be written like this, that P input there R cross 1 and 1 cross R as W, and B is the bias 1 cross 1, and n is finally 1 cross 1, and the output will be also 1 cross 1, and where a will be the function of wp plus p. So now you see here multiple layers of neurons with the multiple inputs. So here you see P1, P2, PR are the only inputs, but the layers are S layers are there, N1 to Ns, and corresponding functions are there. These functions may be same also, may be different also, and corresponding output will be generated A1 to AS. Okay, and you see here the P1 is connected to all R. That means all S neurons. So B1, that means weight for P1 is connected to first one is W1 1, and last PR is connected to S neuron. That's why the weight is WS comma R. Okay, so you can say this, if this node is connected to this, the weight of this will be W of 2R, because it is connected to second layer and the R is the input, like that. So these are the different weights for connected inputs, and these are the different bias. So number of inputs and number of neurons may be different, and this shortened new notation for this will be like this. That means R input and R cross 1 P S cross R. Okay, we are considering this whole as S cross R. S cross R and S cross 1 as the input, and this B is this complete vector. This will add to corresponding, and output will be S cross N, S cross 1, and this A will be also S cross 1, the layer of S neurons. You see this 3-layer network in abbreviated notation. That means multiple layers are there of neurons. That means W1, that is having the S1 and R as the input. So S1 numbers of this one, and this N1 is the S1 cross 1. Then here output is S1 cross 1. And when other weights, and suppose this is having a different number of neurons, S2 neurons, this is having S3 neurons, and here the base is S2 that, and here the output is A2, here final the output is A3, and you see corresponding like this. So what will be A1? The first output will be here, that will be the driven by this function 1 F1, and what is the pass through this? It pass through this is W1P plus B dash. Okay, W1P plus B dash is passed through this, and A2 will be F2 W2 A dash plus B square passed through this, and A3 will be F3 W3, because input is going here W3. A2 is coming here, A2 and W3 multiplied, and plus B3 is coming from here, and that will pass through the F3. So if we put the iterative method, in iterative method, this will be the overall transfer function for this 3-layer network. Okay, and this is the, you can say, beauty of a neural network. We can give chain, and we can get the a complicated problem solved in a very easy manner. So next is delay element. Delay element and integrator both are used in the recurrent neural network. In the delay element, just used to make a delay, whatever the input is coming, we can make and this A0 tells us the initial condition at t equal to 0. Okay, the delay is given at t equal to 0. Till we not initialize, this delay will be not happen. And in integrator, we can say here, this is the sign of delay and this is the sign of integrator. And here also the input A0 is given, and where A0 is initial condition, and this AT is given by 0 to t, u tau, d tau, and A0. So now we see what are the recurrent network. In a recurrent network, we can use this delay and integrator and other elements like that. So in the different network with feedback, like control system. In control system, what we do? In control system, we very well know the open loop control system, closed loop control system. And with the closed loop control system, the stability increases and many other things are beneficial, gain increases. Okay. So like that, we can have a recurrent network in the neural network also. And some of the outputs are connected through its inputs. So you see here the output is connected to the input, and it is more powerful than the feed forward network. The network till now we have seen are the feed forward. That means we are giving input to the back from forward. It is not going back. Okay, so it is more powerful than the feed forward networks, and this can exhibit a temporal behavior. That means we can something use in times that whatever the time is coming, present data will go in the back, will give the input and will work accordingly. So these are recurrent networks are useful for the more real-time systems also. So now we see a problem. A problem is that how to solve a simple problem using the neural network. So suppose a fruit dealer receives orange and apple mixed together in a truck, and he want to load all these fruits over the conveyor belt and want to a automated process to store the orange and apples in a separate bin using the neural network classification. So what is done for that? So sensors are used to detect the features of the input is apple or oranges coming there. Okay, so sensors can use to check the shapes, texture, and weight. Okay, and using the help of neural network, sorter is there. Whatever it is coming, it sort the apple and the oranges separate bins. Okay, so shape, suppose it is given like that. Shape is 1 when the object is round. When it is not round, it is -1. Texture output is from the sensor. So I'm talking about the sensor. And texture output is 1 when it is a texture is smooth, and -1 when the texture is rough. Weight is when it is more than half kg, then weight is 1. When it is less than half kg, then this output is 1, -1. So now we input. So we can use input P as a shape, texture, weight as an input. So we have to make a prototype vector that if this will come, this we can select as a orange. If this will come, we can select as a apple. So prototype vector is given for the oranges 1 -1 -1. So we can see here that shape is 1, shape means round for the orange, and texture is -1, that is rough, and weight is less than half kg for orange. And for apple, you see shape is round is 1, and texture is 1, that is smooth, and weight is less than half kg. Okay, so these are two prototypes. Thus, neural networks will receive one three-dimensional input vector for each fruit and will sort it by the taking decision whether the fruit is orange or apple. Okay, so we can see here, we can take output A, output of this A as hard limit S. Okay, I told you about hard limit. That means we have to classify the things. And S means symmetrical. S means symmetrical mean the plus man or -1. If it is only hard limit, that is between 0 or 1, and if it is hard limit S, then it will be -1 or 1. Okay, so this will be like that: W11, W12, W13 weights. Then this P1, P2, P3 vectors, which we get from the sensors, plus B, that is the bias vector. Okay, So now you see that there are 3 dimensions of properties. Okay, so P1 is this side, P2 is X small, you can say, P1 is Y, and P3 is Z, like that. So we see prototype vector P1, that 1 minus 1 minus 1 will lie in this given quadrant, like that. Okay, and P2 will lie this side, right side, and P1 will lie left side to the P3 axis, Z axis. If you see this P1 P3 plane, okay, if you see the P1 P3 plane, so that plane will divide exactly this P1 and P2 vectors, prototype vectors. Okay, so if it is exactly dividing this, so that can be considered as boundary of, that is decision boundary for these 2 vectors. Okay, so this boundary will gives us P2 equal to 0 equation. P2 must be equal to 0 if you want to divide these 2 prototype vectors equidistant from all the points. So this plane will work fine. That is P2 equal to 0. That means P1, P3 plane, that is, you can say, Z plane, consider vertical one. So when P2 equal to 0 will be equation for the decision boundary will be at middle of both of prototype vectors. Okay, so this prototype vectors decision boundary will be in between that. So P2 will be equal to 0, will be the possibility that it gives the exact thing. And when P2 will be 0, when P2 will be equal to 0, when we choose our W equal to 0, 1, 0 and B equal to 0. You see that when W is 0, 1, 0, P1, P2, P3 plus 0, that will give the equation P2 equal to 0. Multiply P1 will be 0, P3 into 0, and P1, P2 equal to 0. That will give us condition. So that's how we retrieve the possible weights. I told you that everything in the machine learning is to find it out, machine learning neural network, find out the exact weight and the bias. If we are able to solve some problem, then we are on the right path to solve the problem. Okay, so here we have determined the weight as perfect weight as 0, 1, 0 and the bias b equal to 0. So now suppose in case of actually orange came on the belt, then the prototype was 1 minus 1, 1. So P1, P2, P3 will be 1 minus 1, 1. And as we have determined the weight 0, 1, 0 and 0, if you multiply these as a matrix, the output will be minus 1. So if it is minus 1, and then we have to consider it as a orange, and when it is plus 1, then we have to consider as a apple, as a binary classification always. Okay, so in case of orange is coming, so it will be minus 1. So now in case of apple is coming, when 1, 1 minus 1 was there, if you multiply both, so output will be 1. So this will tell us that the apple is selected there, and that will be sent to the apples bin. Suppose by mistake, not by mistake, suppose by mistake, not by mistake exactly, the orange which was came on the conveyor belt was not in round shape. It was not in round shape. Okay, so the vector first will become minus 1. So that minus 1, minus 1, minus 1 will be the vector which is detected by the sensors, and that vector will be multiplied to our vector. So if you multiply our vectors also, this will give again minus 1. So still we can say we are identify the orange correctly. Why we are able to identify correctly? Because this minus 1, minus 1, minus 1 vector is more close to the prototype vector of the orange compared to the apple vector. So that's why we are able to identify this small orange, which is what not in the round shape, but due to its rough out shape. Okay, so the input vector closer to the orange prototype vector, apple prototype vector, will be classified as an orange. So thus most important part of the process selection, W and B, for the correct classification. And the solution, complete solution for problem complete solution for the problem is like this, that we have to choose this 0, 1, 0, b equal to 0, and n equal to output will be there, p will be the input that will given by the sensors. And if this, you see, hard limit symmetrical means it is +1 if it is apple, -1 if it is orange. It will decide between the n is +1 or -1. Okay, and where p is the vector that depend upon the shape, texture, and weight by the sensor. So this will be the solution for this simple problem. Similarly, we can solve other problems also like that. So Pandey sir.
Yes, sir.
How much minutes we can go further? Accordingly, you tell me.
Sir, still we can have 5 to 10 minutes.
5 to 10 minutes.
Yes, sir.
Okay. Hmm. I want to give you some small glimpse of this k-means algorithms also. So in the k-means algorithms, generally we know, but there are some drawbacks of the k-means algorithms also. I will let you know that also in a very short 10 to 15 minute this lecture of introduction of this different initialization techniques for the k-means algorithm. So in this short, we will go through the what is the k-means algorithms, why we need proper initialization for k-means algorithms, what is the k-means plus algorithms, what are the where the k-means plus algorithm is not useful, what is the scalable k-means algorithms. So these k-means plus and the scalable k-means plus algorithms are the very new algorithms developed in 2007 and 2012 respectively. So okay, so what is the natural grouping of among these objects? What is the natural grouping among these objects? Upper objects are there. If we want to classify, we can do two types of clustering. One, that suppose we ask a question that put all the objects in one cluster which have equal sides. Okay, so first clustering is possible. All yellows are having the equal sides, others are not having equal sides. And suppose we ask other question that take all round objects are having non-sides and others non-sides. So we can place a round object in one, another in place that. So clustering is subjected to what question we have asked for the particular group of objects. Okay, so this was something about the clustering. Now k-means algorithm fact that the most popular algorithm used in scientific industrial application identify that the top 10 most algorithms in data mining used for the acoustic data speech understanding convert the waveforms into k categories, also used in image processing. So in k-means we have to group the data in k clusters and attempts to group data points, and here we try to minimize the sum of square distances to central mean. Okay, that means whatever their central mean is there for different clusters, the sum of the square of distances must be minimized. So this algorithm works by iterative between the two stages until data points are converges. Okay, so given data set x1 to xn, which consists of n random instances of data d-dimensional equidistant variable x. So introduce k prototype vectors mu k. That means we have to find k centers which correspond the mean of this mu k correspond to the mean of the k clusters. Okay, and goal is to find the grouping of data point prototype vectors minimizes the sum of square distances of each data point. So how we perform: randomly initialize k centers, decide the class membership for all the objects by assigning them to nearest cluster center, re-estimate the k clusters by assuming the membership found above is correct, and if none of the objects change membership in the last iteration, exit, and otherwise go to step 3. This will be more clear. Suppose we want to perform, this is the data set, and we want to perform this clustering for k equal to 3. That means we have to divide whole data into 3 clusters. So how to do the k-means clustering? So we have to identify 3 random points in the whole data set. It may be the same data points and it may be the different also. If it is the same points only, then it becomes k midwide. Okay, so for k means we can take any 3 points. So now we have to see these red ones belong or nearer to which cluster, which center it is nearer. Okay, so suppose these 3 partition happens, these points are coming nearer to k2, these green points are coming to k1, and these other points are coming to k3. So these 3 clusters have been formed just by taking initial cluster as k1, k2, k3. So now what will happen if we calculate the centroid or mean of these distances square of this cluster? So this k1 will shift this side. Because why this will shift this side? Because more number of nodes are here, and this k2 will shift here and k2 will shift here. So new centers will be here, k1, k2, k3. Okay, then if we again calculate this centroid, check. So this point which was earlier belonged to k1 now belongs to k3, and this belongs to k2 which was earlier belongs to k1. Okay, so this point changed. That means we have to see again and again that each data points belongs to which cluster. Okay, then again centroid will move forward. Okay, so we can say that finally when it is not changing, then it is converging happening. Okay, and overall when it is not changing, that means centroid is remaining fixed. Then it is not changing, then we can say that it is converged, and k means algorithm is done with the optimal centers. You see this thing, this is happening like this. K means clustering inhibition for k equal to 4. Center is moving, points are changing. So now for these data set, you see, starting from the random 4, we settle down to these clusters because these centers are minimizing for k equal to 4. I am giving you one simple example also, so you can understand it for k means. Suppose we have data set 1, 3, 8, 11. And we want to perform for k equal to 2. And suppose we have chosen data points 7 and 10 as a center. Okay, so 138 will belong to C1 because 138 are more closer to 7 comparison to the 10, and 11 belongs to C2 because 11 is more closer to 10. Then we have to calculate its mean. Mean of 138 is 4, and C2 was because it was single one, so it will mean will remain same 11 only. So the new centers, updated centers are 4 and 11. Then we have to again check 1, 3, 4, 8 are closer to whom? 4 or 11, because new centers, earlier center were 7 and 10, now new centers are 4 and 11. So when we see that 1, 3 will belong to C1 and 8 and 11 belong to C2. So then we have to again find the centers C1 and C2. So new centers will be the average of 1, 3 is 2, average of 8 and 11 is 9.5, and this problem is converged. Converge means now if with these centers 1, 3 will always belongs to 2 and 8 and 11 always belongs to 9.5. It is not going, C1 and C2 not going to change, so problem is converged. So that's how with this simple example we can say this K-means algorithms, you can say we can understand it very properly. So but why we need proper initialization? What is the meaning of initialization? Meaning of initialization is that how to choose initial centers so that the proper clustering is happening. Okay, so what happens if sometime we do not choose the proper centers, the algorithm may be trapped in the local minima. That is the problem. Okay, so we can say here, we can see it here, what is the problem of local. So K means initialization we see. So suppose these are the clusters. So suppose we have chosen 4 these cluster centers like this. So what will happen? If you have initially chosen like this, so these will be the 4 finally clusters. This will belong to this one as a K-means algorithm. These will be 4 clusters if these 4 are chosen like this. But actually 4 clusters will be like, should be like this, all 4 separate. But due to the wrong initialization, this clustering is happening like this. So here we can say this is not a correct option. This will go in the, they can say, wrong minima, local minimum. So intuition for the solution that K-means samples 1 point iteration should be updates for its distribution, and cluster head selection by sampling each point independently with the larger probability. So we will see this algorithm is given 2007 K-means plus plus. In that one, what we have to do, we have to calculate the probability of each point. Suppose first we have to choose a uniformly random center. One center we have to choose. Then after we have to calculate the probability of each data point, and the point which is having the highest probability will be the next cluster center. And obviously this the point which will have the highest probability will be the farthest point from the point center C1. So suppose we have chosen 1 point here initially, then suppose this point with farthest will come here. Then again the second farthest from these 2 will be here. Then again the farthest from these 3 will be here, like this. So what will happen in K-means initialization, that the points which are the farthest has not become the cluster head will get a higher probability to become cluster head. So that's why the proper initialization happen. Also K-means plus plus example with a simple thing that suppose 3, 5, 6, 8 is there. Then we can say, let's suppose 5 we have selected as a cluster center. Then what will happen? We have to calculate the distance square. So if you calculate distance square from 5, from 3, that is 4, then 1, from 8 it is 9, then square, then the probability conversion. I already told you sum all and divide by that one. So this will be probability. So 9 by 14 we will have the highest probability. So next cluster center will be the 8. Okay. So X equal to 4, 8 will be the second cluster head, and the new cluster center will be 5 and 8. So then new cluster center will be 3, 5, 6, and 5 and 8 will be the second cluster itself as the center. So here we will use this probability formula, to make cluster centers in k-means plus plus. So k-means a wrong initialization problem will be solved. But there is something wrong with k-means plus plus also. It needs k passes over data. Suppose we want to perform the k centers, then we have to calculate these distances k times. And suppose if you are calculating for the 1 billion data, so just calculating for 1 billion data, if you want to make, so k billion passes will be there for all the data. So that will take long time. So there is convergence issue in k-means plus plus. Convergence time. Convergence times is very large in k-means plus plus if data is large, big. But this k-means plus plus provide the optimal solution in case of k-means applications or k-means algorithm. So intuition for a solution for k-means plus plus, that we can make a oversampling. That means take large number of samples, not only the highest probability, choose the first top 3 probabilities as a cluster head and then merge the center. So then the number of passes will be less. So suppose we are doing that for k equal to 4 and oversampling factor 3. That means we have to choose the three clusters at first center and then 3 different centers, then again 3 different centers. Okay, and after getting all sufficient centers, we will merge all the centers, so we will get different things. So what will happen? This is a faster way. Okay, that means k means parallel means scalable. This is scalable k means. This is known as the scalable k means. So scalable k means is the faster than the k mean plus plus, but it is not as optimal as k means plus plus. Okay, but this can be used with a proper accuracy, almost similar accuracy with the k means plus plus, with a very fast rate compared to the k means plus plus. So k means plus plus is again given by same that we having the highest probability for the top 3 or top k factors. It is given in 2012. So if you compare all these 3, that means k means plus plus is strong guarantee, but number of iterations are more. And scalable k means, that means number of iterations are low, but it do not 100% guarantee. And this only k means gives the fastest, and directly we can choose any clusters and we can perform, but there is no guarantee. So after choosing the 3 clusters in the k-means plus plus, we have to perform the same thing, same operation of k-means. That means we have to adjust the centroid. Okay, adjustment of centroid is same all these 3 in k-means, scalable k-means and k-means plus plus, but only initialization is taking care in k-means and scalable k-means. These are the references for this, and these are references for the supervised learning. Thank you all for listening me. Any questions you can ask, discuss. You can email me also, teacher on, and hope you will be motivated towards some research also throughout this thing. But I can say that identify some problem which are little bit difficult in neural networks to solve yourself by identifying 2-3 different subjects. Like you can use a control system. If you have expertise in control system, you can use control system, some feedback things in recurrent network of your own.